Amit Prakash is CTO and co-founder of ThoughtSpot, a company providing artificial intelligence and search-driven analytics. The Sunnyvale, California-based company reached unicorn status in 2019. Its latest valuation is $2 billion. Its clients include Nike, Walmart, and Apple. Before founding ThoughtSpot, Amit was a software engineer at Microsoft and a tech lead at Google. On the show today, Amit's here to tell us about his mission of building a more fact-driven world. Amit, so great to have you here with us. Welcome to the show.
Thank you, Peter. Really excited to be here.
Well, thanks so much for joining us. Now, of course, the main thing I'd like to chat with you about is ThoughtSpot. Before we get to that, right now you're in Silicon Valley running your own startup, but as I understand, you actually grew up in India. How was the journey starting there and now having founded your own company?
Yeah, it's been an interesting journey. So, and a little bit unique, I should say. So in some ways, the journey started with my father. He was a professor in engineering college, and he came here to do his PhD in Purdue, and he got really, really sick. And then he had to go back. And as I was growing up, it was more of this dream that someday I'm going to go to one of the top universities in the US and do a PhD. That was kind of pretty much with me since I was, kindergarten or something like that.
Oh, wow.
And so that was something that, just was kind of a natural part of my life and I had to do. And I was planning to follow footsteps of my father and be a professor in an engineering college and do some research. But by the end of my PhD, I had taken a very, very practical problem. And I liked theory. And in the end, I had produced a solution that was very theoretical. I was proving log-star and bounds and things like that. And I realized that what I produced was very elegant theory, but not very practical. And that got me to, want to work in the industry for a little bit before jumping back into academia. And once I went to industry and started working on interesting problems, that sort of attracted me so much that I decided to just stay. And so that's how I ended up working for Microsoft for a little bit. And then when I joined Google, it was on CMU campus, and I was still kind of thinking I will probably work with Andrew Moore, who was the director and also a professor at CMU, work with some of his students and do some academic work. But it was just too much fun in industry to work on hard problems. And at some point I was like, okay, so I like this, but what's the next thing that I want to do? And the natural answer was to kind of go start a company and invent something new. And that's how my startup journey began.
Now, I believe this is around 2012. Is that right?
Yeah.
So it's interesting because now AI is such a big deal. But 2012, This was, assuming it was not the very end of 2012, it was pre-ImageNet moment, pre-AlexNet. So deep learning hadn't really broken through yet. You're using a lot of it now. And so at that time, what was it that you had in mind that you were going to try to build?
Yeah, so at Google, I was responsible for the team that was building the click-through rate models for AdSense. And so we were training really, really large machine learning models. And it was more of a systems problem than really machine learning problem. We would tweak around with the algorithm and the parameters a little bit. But primarily, it was like, how do you pump essentially billions of training data points, actually trillions of training data points within a week or so through, distributed gradient descent code. And that's what I was doing over there. That was very beginning of sort of Google Brain team forming. And I remember talking to Andrew Ng and Jeff Dean at the time when the team was getting formed and they wanted to work with us on some of the AdSense problems. But when I met my co-founder, Ajit, He had a very interesting and different approach he had already co-founded Nutanix, and he had spent some time at Aster. And he was talking about, when we start a company, I think the best thing to do is to first narrow down a market, because that's the most important thing. So let's go pick a really large market with important problems. And then let's go pick a problem in that space that we think we can solve better than anybody else. And then let's go work on that problem. And analytics seemed like a really great market. A lot of enterprises care about it a lot. It's been one of the fastest growing segments. And we looked at some of the surveys from CIOs, and we realized that for the last 3 years, consistently, CIOs have been saying that this is the most important area for them to get right. And most of the industry was using solutions that were built 10, 20 years ago. And it seemed like a market ripe for disruption. And so that's how we kind of zeroed in on it.
Now, analytics is a pretty broad term, and I'm sure with ThoughtSpot, you cover it in a quite a broad way. But can you give an example of maybe something that, in the early days would fall under analytics and where you thought you could really make a difference?
Yes. So in some ways, it's really simple stuff, but getting it right is probably the most important thing. So what happens in industry mostly is that if you draw two Venn diagrams of like people who really know business, people who are making business decisions, and they see kind of where the competition is coming, where the market inefficiencies are, and are responsible for sales, marketing, and things like that, or finance. And the people who understand data and systems to sort of interrogate data are completely two different set of people, and the intersection is usually very narrow and thin in the middle. And as a result, even though there's been massive investment in data infrastructure and collecting data and making it queryable, people are not able to get the benefit from it. Like imagine if, so one of our customers is Canadian Tire, is one of the biggest retailers in Canada. And during the COVID time, the demand was changing rapidly for them. 1 week it's toilet paper, next week it's exercise bikes, next week it's men's shaving equipment and things like that. And they were supposed to respond to these things quickly. And it was not just that the demand was changing, the medium of selling was also changing, because most of it was brick and mortar and now all of it is online. And they needed something to be able to respond to the demand very, very quickly. And they generate, very, very large volumes of data. In traditional systems, what happens is that to deal with that, you usually sort of aggregate the data to a scale where you can interact with it. And then you put in tools like Tableau and Qlik, where an expert can kind of go and interrogate data. But that creates some distance between the people who need to make the decision and ask the question. And typically it might take a week, in some cases might take a month before the right person can get the answer. So the primary mission for us has been to empower the people who understand the business, who understand the significance of data, to be able to interrogate data and get answers to their questions.
Now, when you started building this in 2012, you talk about your co-founder. Was it just two of you? How did the company start?
Yeah, so it was me and my co-founder Ajit who kind of started hashing out the plans and putting it together. But we were extremely lucky to have sort of very early on assembled some of the really talented people that you could find in the Valley. And we quickly added another sort of 5 people who were really amazing engineers and had a lot of experience and done different things. We had someone who was one of the architects of the BI systems at Oracle. We had someone who was one of the leads for the Google's backend sort of query engine for what's called Mustang internally. We had one of the leads who was building sort of the orchestration systems for Google data centers. And we had someone who had spent his lifetime researching databases at Microsoft. So we had a pretty amazing team to go build an ambitious solution that was otherwise would have been very hard to build.
Mm-hmm. Now, you said key is to find a real problem that people want a solution to, and I gotta imagine that means working directly with potential customers from the very beginning. Do you have any interesting stories there where certain customers really drove the direction you took things into?
So early on, what we did was we kind of spent about 6 months writing very little code and just imagining what the solution is going to be. And it wasn't obvious how we were going to solve this problem of, non-experts being able to get to data as fast as they could. And we iterated through many different ideas. And, in the beginning, one of the things someone said was, hey, what if we built a Siri-like interface? Siri would just come on and you just ask questions and then you get the answers. And we thought about it for a little bit and we said, there's no way that we can do this and make it into a successful product because, given the state of technology, even the best research teams with hundreds of engineers can only get to maybe about 80% accuracy. And if people are asking business questions and making, important decisions, there's not even a 0.1% chance that you could take of giving the wrong answer. So it has to be very, very deterministic. And so we kind of scrapped that whole thing and then went in different directions with a different UX ideas to make it simple. And then one of the people who had joined us said that, I don't need a Siri, but I do need something that takes away a lot of different layers of information that I need to know to be able to ask questions. And even as a developer, when I'm writing code, the simple autocomplete in Eclipse is extremely helpful for me to write code. So if we move the state of the art significantly towards non-technical user being able to ask questions, that will be an amazing product. And that kind of became the inspiration for what we did next, which was essentially we built a Google-like interface to be able to ask questions, but behind the scenes, it was a very deterministic system. And you could think of it almost as a DSL factory. So it's something that can take the entities that the customer would care about, everybody in that company would care about, and then assemble from there kind of DSL and then build an interface where people could ask questions within that DSL, but the UX is designed such that it doesn't feel like you're programming. It feels more like you're just asking questions in natural language. And so that became the foundation of our very first product. And what we did was we went to many potential customers and showed it to them in just design mocks, and it resonated very well. And then it took a long time to build this, like 3 to 4 months. And then we did our first user study. And it was really amazing to see the kind of response from the business users who had never been able to integrate questions. The response we got was, our jaws are on the floor. That was kind of a light bulb moment. It was like, okay, we are going in the right direction. We have a lot more to build, but let's continue building and make something out of it.
I mean, with my covariant hat on, we work on artificial intelligence for automation in warehouses, but specifically robotic automation. But I think what you're talking about is to help decision-making for not automation in the physical sense, but for the whole logistics chain behind retail. So can you say a bit more about that? Anything you've seen there?
Yeah, so I was talking to one of the largest car manufacturers in the world. And as you can imagine, they have a fairly sophisticated operation with parts coming from all over. And it just gets hard for them to figure out what's the optimal way of procuring something unless they can quickly, ask a question and then ask follow-up question. And so they were comparing their life before ThoughtSpot and after ThoughtSpot, and they were saying that they're able to get these decisions much faster and freeing up a lot of time and energy. But B, they're essentially saving millions of dollars by finding the most efficient way to procure something in a given point of time, given the history of all the transactions that they've been able to do.
Now, we've talked about use cases and how people use ThoughtSpot, but I imagine there's a whole other part to ThoughtSpot, which is not just the users, but everything you had to build behind the scenes, right?
Yeah.
What are the things powering it?
So there are three things that the three pillars on which ThoughtSpot stands, and each one is as important as the other. And it all kind of comes together. And so the three pillars are sort of building large-scale systems that can handle a lot of data, the machine learning and AI part of it that makes it intelligent and smart, and then the UX part that makes it intuitive for users who are not necessarily the most technical to be able to get the information that they need. And so when I talk about systems part, essentially what we do is we build a really fast, really efficient indexing system that can index pretty much everything that the user might care about. And so this could mean anything from like names of products to names of customers to street addresses and product categories and things like that. And it builds a map of these entities as to like which column they live in and how do you join this thing to this thing and stuff like that. And this is actually, there's a lot of computer science innovation went into the systems piece because of two reasons. One, we were shooting for a Google-like experience, and that means that every keystroke returns under 100, 200 millisecond. So it just feels kind of natural. But at the same time, it's an enterprise world. So everybody's permission is different than everybody else's permission. So one person might be the store manager for all the stores in California, and the other person might be the supply chain management who can see all the data around supply chain for United States, but nothing else, right? And so as someone hits a keystroke, you need to go in the back end and look for everything that they can access. And this sort of somewhat overlapping sets indexing becomes a really hard problem. And you're trying to run essentially kind of compiler on top of it. The next piece in this system is this DSL factory that kind of builds a language and a compiler and auto completion system for it on the fly. And over there, the interesting thing is that this is unlike most computer science languages, that there's no notion of delimiters and things like that. So parsing is more like natural language. Like you can have a product name that contains a comma or a bracket or two spaces in the end, and people are just typing those things. And then the third piece is more around ranking, and this is where some of the machine learning things come in as well, where what we're trying to do is guide a user to be able to ask meaningful, relevant questions in a language that they have no idea that it's actually a language. And they're just thinking in terms of their business entities. So being able to surface within the few keystrokes exactly the right sort of entities and tokens and questions is the most important part of this UX. And then the UX piece itself to essentially do this progressive disclosure where the user gives you a little bit of information and you take that information and present kind of choices that are very limited so that the user is not bombarded with choices. So they kind of progressively build their question without knowing that they're actually doing this thing progressively. So that's the search piece of it. The other part that I haven't talked about yet is the automated insight piece, where after we had mastered the search piece, the question was, there's a lot of things where the user would later wish that they had asked the question, but they didn't think of asking that question. And how can we help the user over there? And that's where what we do is that we build models that says that if the user has asked this question, what are the next 1,000 questions that the user might be interested in? And let's go ask those questions on behalf of the user, and then figure out which 5 or 10 are going to be the most interesting business-wise for this particular user and surface those. And so there's another sort of ML machinery that goes into first generating these 1,000 hypotheses and then evaluating them and seeing which ones are interesting and which ones I should surface. So that's kind of the core stack. I should say that there's a lot of other things that go into just running a large-scale data system efficiently and making it available all the time and upgrading and things like that. But as far as sort of the differentiating part of the stack, these are the things that go into the system.
I really like this notion where you have to rank the results based on interestingness, right? But then you're saying you can create another 1,000 queries behind the scenes that are natural next queries, and then even rank the results of those. And I'm curious, how do you know which one should be ranked higher? Where's that coming from?
Yeah, so there are multiple sources of information that we have to combine together to be able to do this ranking. So the first one is really where the search, having a search engine in the product really helps us. So just like at Google, if lots of people ask questions about dogs, and then their very next question is about puppies, then you kind of know that dogs and puppies are related, and you want to guide users from dogs to puppies or expand their queries naturally from dogs to puppies. We're doing the same thing. If lots of people are asking questions about revenue and their next question is about cost or revenue broken down by product verticals and things like that, then we kind of take that inference and apply that to this hypothesis generation engine. And that's really significant because most analytics tools are not built on top of this search-based engine, so they don't have that source of data to be able to benefit from that. And the next one is purely statistical, right? So if you're seeing a large anomaly in the data, then obviously that's going to be interesting to the user. So we are looking for either large anomalies or some interesting correlation or some sort of interesting trend that's, again, sort of stands out as an anomaly. Like your entire business is growing at 5%, but your fidget spinners seem to be growing at 200% or something like that. And so just looking at the data statistically and seeing where something stands out. And then the third piece is really the closed loop feedback system, where when we show an insight to the user and they say thumbs up or thumbs down, we kind of use that to infer what was it that was not interesting. So think of it almost like Facebook posts, right? So you can say, I don't like this thing, but you can also say, I don't like this thing because I just, in general, don't like posts from this particular user, or I don't like posts on this particular topic, or I don't like this specific post, but everything else is fine. So we have that kind of a feedback system that flows into this ranking, where somebody could say that, I don't care about costs. I just care about revenue. So don't show me anomalies about cost. Or somebody could say that I do care about cost, but or let's say I do care about revenue, but you're showing me revenue jumped on 4th of July by 20%. I kind of expected that. Or somebody could say that you're showing me that there's a large anomaly where the x-axis is null. That's to be expected. Don't worry about that. So taking all that information together, we do the ranking.
Now, a natural thing I imagine is that even though you say it feels like people type in natural language and it's close to it, that maybe at some point people can use any natural language to type into the interface, right? Especially with recent advances in NLP, GPT, BERT models, and so forth.
Yeah.
So what's your thinking there?
It's one of the problems that I'm really passionate about, and I've spent quite a bit of time finding a solution for this that can be turned into a product. And we also have sort of an alpha version of this thing out there where people are trying and using it. And I've been really excited watching all these advancements coming with GPT and BERT and things like that. But at the same time, my read on this problem is that it's going to take a lot more than something like GPT and BERT to be able to solve this specific problem. And it's, for lack of a better word, and I know some people will frown on it, I think this solution to this problem really lies on how we can represent knowledge efficiently and how we can capture knowledge efficiently. And GPT is capturing a lot of real world knowledge. But I'll give you an example. So I was talking to an airline company, and they were trying out our alpha product and being able to ask the question in natural language. And they wanted to ask questions like, hey, what's the A0 for DFW, or what's the D0 for DFW? Now, A0 in their context means average arrival delay of a flight segment, and D0 means average departure delay for a flight segment. And when they ask what's A0 for DFW, what that means is that what's the average arrival delay for any flight segment where the arrival airport was Dallas-Fort Worth. And when they say, what's the D0 for DFW, what they mean is what's the average flight segment delay where the departure airport was DFW. Now, only the people in that company know this correlation, that when I say A0, this filter changes to arrival airport. When I say D0, this filter changes to departure airport, right? And they're busy people. They're not going to generate a million training examples for you to be able to learn these kinds of correlations, right? So now you have to capture this knowledge from them and then apply it. They might give you one or two training examples, but then you need to find ways in which to say that, okay, in this context, this is the determining factor that's kind of affecting this thing. Same thing, and things get arbitrarily complex. So, like, I was talking to one of the travel agency companies, and one of their prime questions was, how many of my customers are in New York right now? Now, New York happens to have 17 different meaning in their data set. Whether it's the arrival airport, departure airport, hotel, their office headquarters, the travel agent's headquarters, city, state, all the combination of that, right? And in this specific case, what they really want is that their departure date should be less than today, and the return date should be after today. Now, GPT is not going to be able to tell you that, right? So you need some way of efficiently capturing this knowledge, representing it, and then presenting it. So that's kind of one aspect of it that I've spent many cycles just trying to understand what would be the right UX to capture it, what's the right data structures to capture it, what's the right way of inferencing and things like that. But we're nowhere close. The other thing that's actually very interesting over here is that even though natural language is fantastic for short questions, when people go deep into analytics, typically the questions grow very, very fast. And at some point, very quickly, the questions have no equivalent in natural language, right? Give me the revenue for every state for this year, but don't include the revenue coming from all the products that were returned, and discount the revenue for each partner by the margin that we are providing them. Kind of thing is very, very common. When I look at so if you look at Google queries, the average query length is like 3 words. If you look at our queries, the average query length is like 20, 30 words. And at that point, a natural language is too noisy a medium to even communicate precisely the meaning of the question. Whoever you're talking to If you took their question and repeated it back to them, a week later, they wouldn't know what exactly the interpretation for this question should be. So that's one of the reasons we really feel strongly about the DSL engine that we have is kind of necessary for this product to work. But at the same time, if we can build a very reliable, 99.9% accurate translation layer from natural language to this DSL, that will definitely move the state of the art.
Let's say I were to use ThoughtSpot and I'm typing things into that interface. What exactly would that look like? I guess I cannot type fully open-ended natural language, but it's going to feel like natural language. So how do you make that happen? What does it look like for me?
Most people have either learned or it kind of comes naturally to them that if they're looking for Starbucks near them, they just say Starbucks near me. They don't say, give me a list of Starbucks within 5 miles from here, right? And same thing happens in our search engine as well, right? So if you want to know revenue for last 3 weeks, you just type revenue last 3 weeks. You're not going to say, give me the revenue of last 3 weeks. I mean, that's an easy problem to solve, but what you're trying to do is just get users used to the idea of think of the important entities in your question and just type those entities and you'll get the answer. Right? So you can say revenue for North America last 3 weeks, and that will give you the answer.
Now, you mentioned that people are busy. They're not going to want to supervise a translation engine between natural language and the lingo that they use within the company. But one of the nice things about the recent language models like GPT is that they don't require super explicit supervision. They just require data from the right domain. So I'm curious about your thoughts. What if you can just access internal communication channels, right, where that internal language would be in heavy use and retrain the language model or fine-tune it on that?
I think there's definitely something to it. This is one of those areas where, like, if I can get my hands on that, I would love to, try something like that. And maybe in some time we will. But I also, right now at least, struggle to see in that unsupervised way, where do you get that information efficiently from? So, like, when I say, what's the longest movie ever? Does that mean the duration of the movie? Does that mean the length of the name of the movie? Right? If I have an unsupervised data set where like people are just talking about movies, will I be able to capture that inference to be able to correctly translate that question into duration of the movie? I don't know.
Switching topics for a moment, Snowflake and ThoughtSpot announced a partnership, big announcement.
Yeah.
Can you say a bit more about that?
It's been a very interesting partnership for us and somewhat, in early days, somewhat counterintuitive as well. But it just happened to be just exactly the right thing that industry needed. And we are seeing the results of that as well. So when we were getting started in 2012, and we wanted to build this product where you ask a question and you get back a response almost like Google. Part of that deal was that the response should come back in the same latency as Google. Google, in most cases, will come back in half a second, quarter of a second, something like that. And we were trying to solve the problem for entire enterprise, which means that some enterprises have tens of billions of records that they want to interrogate routinely. And you can't pre-aggregate that either because that constrains what kind of questions you ask. So we ended up building one of the fastest distributed in-memory databases around for this problem. And so in early days, when we used to sell ThoughtSpot, ThoughtSpot came with its own database layer where you load all the data and we hold that in memory across, possibly hundreds of nodes. And then when you ask the question, we translate that question from sort of this DSL all the way to very efficient C++, do a compilation just in time, and then run it over these in-memory data structures and come back. That served us well, but with a lot of enterprises moving to cloud and solutions like Snowflake coming in, what we saw was that these databases were pretty fast, and they kind of served the need we were trying to fill. And for the enterprise, it's much better to just have one data warehouse where they put all the data, as opposed to moving that data into yet another database that's just meant for this particular analytical tool. So it made sense for us to work on top of Snowflake. Why this partnership worked out really well was that we were the only analytics tool that was built on the assumption that the database is going to be super fast, super scalable, and can, handle large queries over large volumes of data and things like that. So we were architected that way. So when we started sending queries instead of our own internal database to Snowflake, it just kind of fit right in and created much better integration than what anybody else could create, because most of the other tools in the industry were kind of designed for a world where databases were much slower or dealt with much smaller volumes of data. In some ways, Snowflake kind of removes the constraints around data scale, and we remove the constraint around users' ability to ask questions. And so that kind of was a marriage made in heaven. It's working out really, really well. We have a lot of happy customers who love this combination.
Looking further ahead, what do you see as the future of artificial intelligence in the context of ThoughtSpot?
That's a really interesting question. And there are probably three different directions that we are going to pursue. That's really, really interesting. And each one of these, in some sense, is kind of an AI complete problem. So we'll keep making progress. But until, general artificial intelligence is solved, it'll be somewhere in that spectrum. Right? Uh-huh. So we already talked about this problem of being able to ask questions in natural language and being able to interpret that. So that's one direction where we'll continue to invest and continue to find better and better solutions. What we're finding is that a lot of, at least 80% of the questions that are being asked are just a variation of a question that was asked before. So if we just kind of take the history of all the questions that were asked by the experts before and figure out what's the right way to ask that question in natural language, and then every question in its neighborhood can be answered, then that's a fantastic way to go. So that's kind of our sort of putting the product hat. How can we build a good solution from the technologies that exist today? Spot IQ, which is our automated insight engine, there, I think it's a very interesting problem where if you look at all the advancement in AI, it has served us really well on all the perception-related problems. But when you talk about complex systems, I don't know that it has translated that well yet. Right? I don't know of many people, training very deep neural networks and kind of getting benefit from it by sort of trying to figure out what's the best decision for their business next. And part of it is because a lot of context is still, in people's head, and the kinds of problems that people use, predictive techniques and things like that for are still somewhat like low dimensional problems, right? Like trying to forecast your revenue and things like that. And so we're trying to figure out over there, how can we leverage some of the advancement that has happened in AI in this particular domain in a way that most business users can benefit from it. So there's a whole slew of tools out there that serve the data science persona, right, where they're trying to train a predictive model. What we're trying to do is figure out how to help, marketing manager or a finance controller or somebody like spot patterns in their data and then benefit from that. And a lot of the problem over there, again, lies in how do you capture the context that's in somebody's head to be able to give them something meaningful. So I'll give you an example. If I tell someone who's in retail that your revenue from California is an outlier, they're going to say, tell me something that I don't know. California is the most populous, one of the richest states where I have most number of stores. Obviously, I'm going to have a lot of revenue from there, right? But in that response, what's baked in is the business knowledge that revenue is supposed to be proportionate to number of stores or the population that it's serving, right? How can I capture that in an automated and efficient way so that when I present insights, they're more useful and meaningful, and they just don't look like random anomalies in data. And then the third one is, again, about capturing business context. So as great as we think our tool is, for anyone to be able to benefit from it, there's a lot of steps initially that's involved in bringing that use case up. So let's say somebody wants to analyze their sales pipeline or something like that, right? So they bring in the Salesforce data, then they have to model it as like tables and columns, and then relationship between tables, and then provide business meaning to different columns, like this particular column means revenue, and so on and so forth. And then that's when it gets ready. And so what we're looking to do is figure out ways of making that push button so that people are doing similar tasks hundreds of times across different industries. Can we capture that knowledge and then automate that whole process so that as soon as you connect our product to your data, it knows most of the business context and it can be ready for you to interrogate it, as opposed to some expert kind of providing that knowledge.
No, I mean, in the extreme, of course, that's not a natural thing to do now. What you're describing, some of it sounds like a reinforcement learning problem, right? It's what business decision to make that will more likely lead to higher reward. It's literally a reward in many, many senses in the business environment. Of course, a bit tricky to just let a RL agent run the business. But it's really interesting because some of these ideas of RL these days do apply to offline data sets. You can just do imitation learning, but it assumes that you record decisions made, right? It assumes that somehow what you have right now is a query engine, gives a lot of information, but the question is, do people also register back into it the decisions they made based on the analytics data they got? Because once they do that, then maybe you can actually start learning the connection. And so how do you incentivize people to enter their decisions, their conclusions?
Yeah, that's a really interesting direction to think about. So we recently acquired a company called SeekWell, and what they are into is, the industry term is reverse ETL, where essentially you're pushing data from your warehouse back into the apps. And typically the reason for doing that is to take some action. And so you may decide to send out emails to a bunch of your customers about a particular topic, or you may decide to drop a promotion, or you may, in a procurement system, may push certain items to be ordered with its quantity and things like that, right? So right now what we're doing is just providing convenience. That you may have asked the question that what are the products on which inventory is running low, and what's the difference between the forecasted amount demand and the current inventory? And then once you build that data set, you push that to the procurement system. But you're right, we could start instrumenting that, and then it could be something that could be interesting in the direction of imitation learning, but early days for things like that.
Talk about early days. I think for a lot of people who want to start their own company, a big open question, once you have the idea and maybe you have the team to found the company, is how do you get your first money? How is that for ThoughtSpot?
So we're very, very fortunate in our relationship with our investors, and in particular Lightspeed. They've trusted us from the very beginning and have been amazing in supporting us. So even before we had kind of a concrete idea that we wanted to pursue, because Lightspeed was also an investor in Nutanix, which was Ajit's previous company. We had a strong relationship with them, and we had their backing. And so that part came somewhat easy to us in the beginning. And then after that, it's been really good for us in terms of just being able to hit the right milestones and show success.
Do you have any advice for people who maybe didn't already do a company before and have an investor on speed dial from that?
Two things. One, in general, things have gotten so much better for entrepreneurs than 2012, in terms of there's a lot of desire to invest in sort of brilliant tech entrepreneurs, and there's so many problems that are now accessible because you don't need a really large investment to build a solution. Right, because there's a lot of cloud infrastructure and things like that is already available. So I think a lot of what possibly holds people back in the beginning is kind of their own fear of how to navigate these things. But once you jump in, actually the infrastructure is so much better than before in terms of supporting would-be entrepreneurs. So that's one thing. But the other thing I feel is that there are two ways to start something. One is to kind of have an idea, and you just kind of take out 6 months of your life, investing in it with a couple of co-founders and building something, and then going and showing it to someone. And the other one is kind of, you have an idea and you start talking about the vision and validating it with people. And once you have some validation, then you kind of start investing your time and resources into it. And I see actually the second one working better than the first one, because as fun and as interesting it is to solve problems for engineers like us, it's even more important to get the problem right. And so I think spending more time early on to get the problem right, even before you've written the first line of code, is kind of one recommendation that I would have. And once you have a concrete problem statement that you believe in, you have conviction on, and you have some validation, it gets a lot easier to have those conversations with investors.
Well, that's definitely my experience too. I like the way you articulated that. We actually had a guest on a while back, Keenan Weierbeck from Zipline. And by default, you would think of him as a robotics person because he did a lot of work in robotics and Willow Garage before Zipline. But he said when he started Zipline, it was, robotics was an afterthought. It was delivering medication to hard to reach regions was the problem that needed to be solved, the logistics of healthcare in remote areas. And that from there, everything just followed.
Yeah. So I think getting the market and the problem right is probably the most important thing. And if you can get those things, not necessarily right, but in the right zone, everything else from there, whether it's raising money, whether it's recruiting people, all of those things become relatively easier. It's still entrepreneurship, and still you're shooting for something really, really ambitious. So there's going to be a lot of struggle, but it's definitely one way to de-risk your venture.
So Amit, as I was doing a bunch of reading and watching videos of you yesterday in preparation for our conversation today, one thing that I ran across that really intrigued me was a quote that says, "The best leaders are students." And apparently you put an hour aside every day for yourself to learn something new. Is that right?
Yeah. It's not something that I've always been able to do. But last couple of years, I've made it a point to do that. And it's been really rewarding. And I guess partly I have the pandemic to thank for that, because all the commute is out. So you got to use that time for something. But yes, when I was at Google, I felt like I was at the forefront of where machine learning was at the time. And then I got busy with ThoughtSpot, and so much happened in this field that I had missed. And so a big part of last 2 years when I've spent a lot of time learning was kind of just catching up on the field. But then there are other things that I'm passionate about and I like to learn, whether it's like art or, politics or whatever. So that extra hour that we saved from commute has been really, really fantastic for me to learn and gives me a lot of joy, and it's useful as well.
Seems hard though, right? Because on any given day, you probably have a lot of fires to put out, a lot of things that you want to take care of that are directly useful that day or the next day maybe. And now you're sitting an hour aside where you're not working on those things that could help you today. And so how do you make sure you don't stop doing it?
No, so I think in what we do, probably customers and their urgent needs definitely comes first. And then like taking care of people in the team is kind of the second highest priority. And then you have your strategy meetings and things like that. So in general, those things always kind of take a priority. But I do make it a point to set aside some time. And if it gets preempted, it gets preempted. But just it doesn't get preempted that often. So that kind of works well.
Sounds like things are running very smoothly.
And yeah, the other thing I was going to say was having, someone like Sumitra who's leading the engineering for us, and I'm not kind of in the day-to-day management of engineering, helps a lot as well. So basically hiring amazing leaders who kind of run the organization is the other secret sauce here.
Great hiring as a secret to having time again. Yeah. Well, Amit, it was so wonderful having you on. Thanks for making the time.
Thank you so much. I really enjoyed it. It was a fun conversation.